Okay, so I want to start by talking about the very last problem that I had you do last week, where you got a principal of 4,000, an interest rate of 6%, and a time of 7 years. And you're going to look at all the different ways you could compound it and see which one you would rather have. Well, when you did it, you should have had something like this. So remember, this is the formula for compound interest. It's A equals P times 1 plus R over N raised to the NT. So I noticed a lot of people, what you forgot to do, whenever you put this into wherever you do, whether it's a search bar, whether it's your calculator, whatever, you want to make sure you do not forget your caret. So this caret here is what makes this an exponent. If you don't include this caret, what it's basically doing, it's just multiplying. So you want it to be an exponential, so you want that caret. So when you do this, notice how annually when n is 1, semi-annually n is 2, quarterly n is 4, monthly n is 12, weekly n is 52, and daily n is 365. The more you compound, so the more times it happens in a year, the more money you get. Granted, it might not be a lot more, but it keeps increasing. If you just had it annually, so you only compounded it once a year, you would only have $6,014.52. Whereas you did it every day, you would have $6,087.64, which is like $60 more, which is a lot in the grand scheme of things. So, we're going to learn about one more thing where it has to do with compound interest. And what this is this is when you are compounding continuously. So this means compound continuous. I don't know how to spell continuous, it's fine. So, this means it's not every day, it's not even every second, it's every single, like as soon as it stops, it goes again and again and again and again. And if we think about the trend of compounding, do you think that if we compound continuously, the number will be higher or lower? It should be higher because you keep compounding, and we saw from 1 to 365, we had like $60 more. So the thing about compounding continuously is a different formula. And the reason it's a different formula is because it has that number, E. And what the formula looks like is A equals PE to the RT. So some people call this PERT because it looks like PERT, like the shampoo. So the reason that we don't have that 1 plus R over N is because that is what E does. E is part of the natural log, which means this E does all of this but continuously. So that's why we, instead of that part, we have our E now. So let's do an example of this problem. Let's say you're at a bank and they offer you, and you put in $4,000. So we're going to use the same sort of thing we were just doing with a 6% interest rate, and you want to know for 7 years. So we're thinking about what we just did, but now we're going to be compounding continuously. So everything's the same. This is my P, this is my R, but wait, we can't have it as a percent. What do we have to do? Divide it by 100. And it would be 0.06 because we have to have it as a decimal. Then our time is 7. Now we just plug it into our formula. So I have A equals, my P is 4,000. E, remember E is just a number. I think it's like 2.71 something. I don't remember off the top of my head. E, and then you raise it. So that little caret, and then in parentheses, my rate, which is 0.06, times my time, which is 7. Now, when you put this into a calculator or a search bar, let me see if our calculator even has E. I don't think calculators have E. It does. So my calculator has E. It's right beneath log. So I'm going to put in 4,000 E. Notice that E button. Then I'm going to put my little caret. See, my caret is there. Then I need parentheses, 0.06 times 7, and my parentheses. So notice how you need that caret, or it's going to be wrong. So I have a whole bunch of decimals, but remember, I'm working with money, so I don't care about anything except that penny. So in this case, I would get A equals $6,087.85. So if you put in your calculator, you'd have gotten 0.846. But remember with rounding, because this is a 6, you round this up to a 5. This is just a little bit more than daily, but it proves our point that the more you continuously compound, the higher that's going to be. So this week what you're going to be doing is you're going to be reading a bunch of word problems in real life and trying to think about it. So if you're putting money and you're saving things, obviously you want to have more. Whereas if you're putting money into something as a debt, so say you owe a loan shark or something, don't give money to loan sharks, but say you owe money to someone, you don't want a high interest rate, you don't want a high compounding rate, because that means you will owe them more. This is like what happens when you look for credit cards, which you will be looking at this week. So you want to think about compounding, like we did last week, that formula, and this new formula. You only use this formula when it has the word continuously. If it does not have the word continuously, you use the formula from last week. Remember, you can always schedule a meeting with me on Zoom or anything for any reason. Let me know. I hope you all are doing great and have a good week.